Ever wonder why car mechanics and engineers often seem to clash? You've got two sides who both love cars, but they're constantly at odds. What's causing the friction? Is it a battle of brains versus hands-on experience? Or is there something deeper going on? Stay with us to know more. In the world of cars, mechanics and engineers frequently find themselves at odds, despite both being vital to the automotive industry. Mechanics are the hands-on experts who repair, maintain, and troubleshoot vehicles, while engineers are the minds behind the design and development of those vehicles. The tension between these two professions stems from their different perspectives, goals, and the challenges they face in their work. To understand this conflict, we need to explore the nature of their roles, the expectations they must meet, and how their interactions impact the real world. Engineers are the architects of the automotive world. They design vehicles from the ground up, focusing on every detail, from the engine and transmission to the electrical systems and safety features. Engineers are driven by the desire to innovate, meet regulatory requirements, and push the limits of technology. Their goal is to create vehicles that excel in performance, efficiency, and safety over the long term. Working in controlled environments, engineers rely on simulations, theoretical models, and precise calculations to perfect their designs. They aim to optimize every aspect of a vehicle, from reducing emissions to enhancing the driving experience. However, this pursuit of innovation and perfection can sometimes result in complex systems that are difficult for mechanics to repair or maintain in the real world. On the other hand, mechanics are the hands-on experts who tackle the real-world challenges of vehicle repair and maintenance. They're the ones who roll up their sleeves, diagnose issues, replace parts, and ensure that cars are running smoothly. Unlike engineers, mechanics work under tight deadlines, budget constraints, and the constant pressure to get vehicles back on the road as quickly as possible. Mechanics depend on their experience, intuition, and practical knowledge to fix problems efficiently. While they often respect the work of engineers, frustration can set in when faced with designs that are difficult to work with. For example, an engineering innovation might make a part nearly impossible to access without specialized tools, driving up labor costs and frustrating customers. But a major source of tension between mechanics and engineers is the communication gap that often exists between them. Engineers typically design in environments removed from the realities of day-to-day vehicle maintenance, which means they might not fully grasp the challenges mechanics encounter in a garage. On the flip side, mechanics might not understand the engineering constraints and trade-offs that influence certain design decisions. This disconnect can lead to a clash in priorities. Engineers might focus on cutting-edge technology, sleek designs, or lightweight materials, while mechanics prioritize ease of repair, durability, and accessibility. What happens when that sleek design turns into a repair nightmare? When these differing priorities collide, it often results in frustration on both sides. Take modern car engines, for instance. With the integration of electronic control units, or ECUs, turbochargers, and hybrid systems, engines have become more complex. While these advancements boost performance and fuel efficiency, they also make engines harder to service. Mechanics often find themselves struggling with limited access to certain components, which leads to longer repair times and higher costs for customers. Another example is the use of non-standard fasteners or specialized tools in car assembly. Engineers might select these to reduce weight or improve assembly efficiency in the factory. However, mechanics often find these choices frustrating, as they might need to purchase expensive proprietary tools or spend extra time figuring out how to disassemble a component. Technology is a double-edged sword in the dynamic between mechanics and engineers. On one hand, technological advancements have enabled engineers to design vehicles that are safer, more efficient, and environmentally friendly. On the other hand, these advancements have made vehicles more complex, challenging mechanics to keep up with the latest diagnostic tools, repair techniques, and software updates. Modern vehicles are equipped with numerous sensors and computer systems that monitor everything from engine performance to tire pressure. While these systems offer valuable data for mechanics, they also bring new challenges. Diagnosing issues often requires specialized equipment and software, and interpreting error codes can be a complex task. Mechanics must continually invest in training and new tools to stay current with the latest technology, which can be both costly and time-consuming. Software now plays a critical role in modern vehicles, controlling everything from the infotainment system to the transmission. Engineers frequently release software updates to fix bugs, enhance performance, or add new features. However, these updates can also introduce new problems, frustrating mechanics who must troubleshoot issues that didn't exist before. Additionally, as vehicles become more software dependent, the lines between mechanical and electronic repairs blur, requiring mechanics to develop new skills in coding and data analysis. The increasing complexity and reliance on technology in vehicles continue to challenge the relationship between mechanics and engineers, making it essential for both sides to adapt and collaborate efficiently. The debate over proprietary systems and the right to repair is a major source of tension between mechanics and engineers. Some automakers have introduced proprietary systems that limit access to essential diagnostic tools, software updates, and repair information. This forces mechanics to either rely on authorized dealerships or purchase costly tools directly from the manufacturer, making it harder for them to operate independently. The right to repair movement advocates for greater access to repair information and tools, arguing that both consumers and independent mechanics should have the freedom to repair their own vehicles. Engineers and automakers, however, often defend these restrictions by citing concerns about safety, intellectual property, and maintaining quality standards. This debate underscores the ongoing struggle between the practical needs of mechanics and the control exercised by engineers and manufacturers. The conflict between mechanics and engineers has far-reaching consequences for the automotive industry, influencing vehicle design, manufacturing, customer satisfaction, and the overall cost of ownership. Customers are directly affected by the friction between mechanics and engineers. When vehicles are designed in ways that make repairs difficult or expensive, it can lead to frustration and dissatisfaction. For instance, a car owner might be dismayed to discover that a seemingly simple repair requires the removal of an entire engine, leading to a hefty bill. In such situations, customers often blame both the mechanic for the high cost and the engineer for the inconvenient design. As vehicles become more technologically advanced, repair costs have risen. The complexity of modern cars drives up the cost of diagnostic tools, specialized parts, and labor, which mechanics may pass on to customers. This results in higher overall ownership cost, potentially deterring buyers and impacting automaker sales, especially in markets where affordability is crucial. The tension between mechanics and engineers also affects the aftermarket industry, which includes independent repair shops, parts suppliers, and third-party tool manufacturers. When automakers restrict access to repair information or use proprietary systems, it limits the availability of aftermarket parts and tools. So, what are your views on this subject? Please let us know in the comments section below, and don't forget to like, share, and subscribe to our channel. And thanks for watching, and we'll see you in the next video. See